welcome back to Geo. We are at 1.5 measuring segments. So let's go ahead and start with the easy question involving the absolute value. The absolute value of negative 10 would be positive 10. Let's fix that. And now I can, right? So, and then the other thing is when we do the absolute value, we first have to add or subtract everything inside the absolute value first. So we do this inside first, and then we take the absolute value second. So it becomes 9 minus negative 3, which becomes plus plus, so we get 12. The absolute value of 12 is going to be 12. Next, again, we do not change negative 8 or take the absolute value of negative 8. We first have to add these up. That gives me 1. The absolute value of 1 is 1. And then next, 7/3 plus negative 2 over 1. Let's find the common denominator. Multiply by 3 and 3. 7/3 plus negative 6/3 leaves us with the absolute value of 1/3, which is just 1/3. And so what you see from all four answers is that each answer is positive. And that's because when we think of absolute value is really the distance away from 0. So how far are we from 0? And it's not possible to walk negative 5 feet. We can walk 5 feet to the left, or we can walk 5 feet to the right, or we can walk 5 feet straight ahead, or we can walk 5 feet backwards. Okay, so when we deal with the absolute value, it's just like distance, it always becomes positive. Alright, next, it says draw a number line. So let's do that. I'm going to draw our number line. Let's put negative 1 at this point, and we're going to put positive 5 at this point. And this is going to be point A, and this is going to be point B. And so we're being asked to find the distance between these 2 points. Now, an easy way is we can just put marks, like this would be 0, and this would be 1, and this would be 2, and this would be 3, and this would be 4, and then we're at 5. And so to count distance, I mean, really I could just count from A to B, which would be 1, 2, 3, 4, 5, 6, or if I went from B to A, 1, 2, 3, 4, 5, 6. So we know that our distance is going to be 6 units. Okay, however, I could have also have started with the endpoint of A of negative 1, and then subtract that from the endpoint of B, which is 5, and then negative 1 minus 5 is negative 6. The absolute value of negative 6 is going to be positive 6. Okay, and just like I went A minus B, right, so I can do the absolute value of A minus B, or I can do the absolute value of B minus A. So if we went the other way, with B first, it'd be 5 minus negative 1 for A, and then that becomes plus plus, the absolute value of 6 is also going to be 6. So more than one way that you can solve this problem. Alright, so then we have our rule of postulate, which says the distance between 2 points on a number line A and B is the absolute value of B minus A, or the absolute value of A minus B. These signs will slant sign meaning the absolute value. Alright, so down below we're being asked to use the rule of postulate to find the distance between these 2 points. So again, you have options. You can say negative 3 minus 4 and take the absolute value. That gives you negative 7, which turns into positive 7. You can also just count from negative 3 to 4. 1, 2, 3, 4, 5, 6, 7 units. So again, it's nice to have options. Negative 2 minus negative 11, and that becomes the absolute value of 9, which is again going to be 9 units. And then let's do 12.5 this time, minus 2.7. We have to borrow, that's going to be an 8, 9.8, and the absolute value of 9.8 is going to be 9.8. Oh, and I also put units here. we have FH, and for FH, for these I would just count. So FH 1, 2, 3, 4, 5, 5 units. GJ 1, 2, 3, 4, 5, and 6 units. And then JF, we have, we're gonna count left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And HF, 1, 2, 3, 5 units. Alright, now this part is very important. Let's put a star here. You want to review this a few times before you do your quiz. FH refers to the distance. Alright, so this is going to be an exact distance in units. Therefore, FH in this problem referred to 5 units. So we have 5 units. Segment FH is just segment FH. There's no unit, length, or distance that's attached with segment FH. So these two are not equal. They are not the same thing. And by now, I think you know that since a segment has 2 endpoints, that a segment cannot equal a ray. And a ray, since it has 1 endpoint and then goes on forever, cannot equal a line because a line has no endpoint. The line goes forever in each direction. So these 4 items, even though they look like they might be the same, they aren't the same for the reasons that I just explained. Alright, next we have segment addition postulate. If points A, B, and C are collinear and B is in between C, then AB plus BC equals to AC. So using that new postulate, we want us to write an equation for the following line. So we have EF is 12, and I like to usually mark which unit or which segment is what. So EF is 12, I'm going to put a 12 here, so we're saying that the length from E to F is 12. And then the length from F to G is going to be 21. And when I add each of these segments up, it's going to equal the entire segment, which would be described as segment EG. So we're going to get 12 plus 21, and that's going to equal 33. And so EG with no line over it is going to equal 33. Alright, so that gives me 33. Alright, and then next we have EF is x minus 7. So instead of 12, sometimes we'll use algebra. So let's change this. We now have x minus 7 is 50. And then FG we're told is 19. So x minus 7 plus 19 equals. And then EG is going to be 33. And so I plug in 33 there. And then same type of problem. X plus 12 equals 33. Minus 12 on each side. X equals 21. So we get 21 there. Okay, we're back to geometry. Once again, please hit the pause button if you need to write down the following definition. Alright, we're going to go ahead and start with our midpoint. And so midpoint is a point that divides a segment into 2 congruent parts. Let's make a quick drawing so we understand what that looks like. We had A and B, so here's segment AB. And we were told that there was a point in the middle that was called the point M, such that M was halfway between A and B. That means M is our midpoint. So put 1 mark here and 1 mark here. And by doing that, you're saying that AM is congruent and equal to BM. And that's what makes M our midpoint. Alright, so segment AM is congruent and equal to segment BM. Next term that we have is called a segment bisector, and we want to make that drawing as well. It's going to be tough to do with our space divider, but let's make a drawing down here. So first, let's with our segment AB. So there's segment AB. And this time we're going to cut this segment in half with either a point, a line, or a plane. And usually it's done with a line, so we'll do this with a line, but it can also be done with a point or a plane. So if we use a line to bisect segment AB, the line can do anything we want. I mean, it can go straight up and down, it can go diagonal to the left, it can go diagonal to the right. So I guess let's make ours go diagonal to the right. It's going to hit, and then this line's going to keep going on forever. And so let's label this point at the middle. We'll say this is point M again. And what this line did is it now made AM is equal to BM, just like in our midpoint. So again, I could say that AM is equal to BM. And let's say this is line T. Okay, and so I can say that line T is my segment and then bisector. Okay, so line T will act as the segment bisector. AB is not the segment bisector. AB is the segment that got bisected. Okay, but line T is the segment bisector. Alright, so here we're going to fill in a line and a ray cannot be bisected. And the reason being is that a line will go on forever. So how do we know what half of forever is? We don't know. It's a lot, but we're not sure. And same with the ray. A ray is going to have one endpoint, and then it's going to keep going on forever. We're not sure how far that is. So a line and ray cannot be bisected. Only a segment for right now can be bisected. Alright, then our next term is called a perpendicular bisector, and we want to make another drawing for that. So I guess let's make our drawing over here. So let's start again with segment AB. Here's segment A, here's segment B. And this time, when we draw our line, now here for a perpendicular bisector, we can have a segment, ray, or a line. Okay, so there's three choices that we have. And I guess let's make this be a line again. And we'll have this line, and this time the line's going to go straight up and down because we're going to create a window of 90-degree angles. So all these angles are 90 degrees. So we can put 90 degrees, 90 degrees, and 90 degrees. The other mark that we can make is that we have this point at the middle. We're going to call this point M again. And we can put a mark here and a mark here because segment AB was bisected. Okay, and this again is our line T. So I can say that AM is congruent equal to BM. We have four 90-degree angles at the center, and so that's what makes it a perpendicular bisector. Again, I would have to state that line T is my, and then this mark right here means perpendicular. So line T is my perpendicular, and then we need to include the word bisector. Alright, if L is the midpoint of AB, then I can say that these two segments are congruent. So I can say AL is congruent equal to EL. And that's by definition of midpoint. If R is the midpoint of MN, then I can say that segment Mr. is congruent equal to segment NR. And that's also by definition of midpoint. Alright, GH and BF and intersecting at point E. Alright, so let's draw that out. We have segment GH and BF intersecting at point E. So let's put BF here, and we have point E in the middle. Alright, so we're told that DE, this length from D to E, is going to be 3x minus 5. And we're told the length from E to F is going to be 5x minus 9. And so they want us to solve for x. And we're told also that E is the midpoint. So what I can do here is I can put a mark here and a mark here, meaning these two segments are each congruent. So we're going to take 3x minus 5 is going to equal 5x minus 9. Solve for x, negative 2x equals negative 4x equals 2. Remember that when you solve for x, we didn't have to plug 2 back in. So 3 times 2 minus 5, 6 minus 5, we get 1. So DE is equal to 1. And then EF is going to be 5 times 2 minus 9, so 10 minus 9, and we get 1 again. And that should make sense that these two lengths are the same. So we have 1 and 1. Alright, problem 14, we have GE, EH, and GH. So let's draw this again. Here's G. We'll put E here, and GE is y plus 3. And EH is going to be 2y minus 4. And then we're told that when we add these two up, that it's going to equal the entire segment, which is going to equal 6y minus 10. Now this problem is different than problem 13. On problem 13, we were told that E is the midpoint. We're not told here that. We're being asked, is E the midpoint? So I can't set these two equal to each other because I'm not sure if E is my midpoint. So we're just going to use algebra. Y plus 3 plus 2y minus 4 equals 6y minus 10. Solve for y. 3y minus 1 equals 6y minus 10. Negative 3y equals negative 9. Y equals 3. Again, we now have to plug 3 back in. When I do that, that means I'm going to get 3 plus 3 here, which would be 6. And then 3 times 2 is 6. 6 minus 4 is 2. So clearly E is not the midpoint of GH because G is 6 and EH is 2. Alright, and then down the bottom we have if H is the midpoint of segment AT, then AH is equal to TH. That's definition of midpoint. And we're not there yet, but we would use this in proofs, and we'll learn proofs next unit. This is kind of the
Good afternoon, Westview. If you have an off-roll, off-roll stickers are available starting today in the plaza at lunch. Again, if you have an off-roll, please go to the center of the plaza to get your off-roll sticker for your student ID. Thanks and have a great day.
And if A is between P and R and PA plus AR is equal to TR,